Good morning, dear. Today we will correct number 7, page 11 in your volume 2. So if you please put your homeworks in front of you and follow with me. The first one, calculate 6 over 4 plus 3 times 1 over 8 plus 1 over 7 minus 1 times 3 over 8 plus 16. The first step is to solve these addition and subtraction expressions in order to have a normal fraction. So 4 plus 3 is 7. It's 6 over 7. 7 minus 1 is 6. 8 plus 6 equals to 14. So on the line, I have to write them properly. Here we have 6 over 7 times 1 over 8 plus 1 over 6 times 3 over 14. Okay, now we have multiplication, addition, and multiplication. According to PEMDAS rules, the priority goes for multiplication. While we are multiplying fractions, we multiply the numerators by each other and the denominators by each other. So I have to write 6 times 1 is 6, 7 times 8 is 56, so it's 6 over 56 plus. Multiply the numerators, 1 times 3 is 3, and 6 times 14 is 84. Okay, now to add fractions, we should have the same denominator. Now let's try to simplify to check up if I get the same denominator or not. 6 and 56 are both even numbers, so they are divisible by 2. 3 is not an even number, it's not divisible by 2, and we know that I divide both terms, the numerator and denominator, by the same number. I can't say, for example, here minus divide by 3 above and divide by 2 below. It's not correct. I have to divide by 3 or by 2 or whatever the number is in both the numerator and denominator. So 6 divided by 2 is 3, 56 divided by 2 is 28, and then I write plus 3 divided by 3 is 1, and 84 divided by 3 is 12. Why? It's 28. Why did I divide it by 3? Since the sum of its digits here is a multiple of 3. Now we have the same denominator, which is 28, so I simply add the numerators. 3 plus 1 is 4, and we keep the denominator as it is. The result is 4 over 28, so I have to write it as irreducible fraction. Both are divisible by 2 and also by 4. So directly I have to say divide by 4. 4 divided by 4 is 1, and 28 divided by 4 is 7. 1 over 7 is an irreducible fraction. So here I can say that I calculated it, and that's how I show all the steps of calculation. Now part B. Here we have multiplication, subtraction, multiplication, and subtraction. According to PEMDAS rules, the priority goes to multiplication. So I have to solve the multiplication first and then continue. 1 times 5 times 3. So I multiply the numerator by each other and the denominator by each other. Okay, here we have times 3 and divide by 3, so I simplify them directly. You can multiply and then simplify. Similarly, here in the presence of multiplication. So let's write the answers. 1 times 5 times 3 is 15. 2 times 6 times 4 is 48. Minus 2 times 1 is 2. 4 times 4 is 16. So it's 2 over 16. Minus 5 over 48. If I look here, there's the same denominator, 48 on both sides. even if here I have 16 times 3, I will have the same denominator. Okay, if I didn't simplify first, it will be 6 over 48. But it's okay, I'll keep it here as 2 over 16. I simplified first. What to do? How can I say that 16 becomes 48? I have to multiply it by 3. Then it's 15 over 48 minus 6 over 48 minus 5 over 48. We have here the same denominator, so what to do? I have to subtract normally. 15 minus 6 is 9, and their answer 9 minus 5 is 4, and we keep the denominator as it is. Okay, it's 4 over 48. Both are divisible by 4, so I divide to make an irreducible fraction. 4 divided by 4 is 1, and 48 divided by 4 is 12. Keep in your mind that I have to simplify when possible. Okay? Part C. Here we have 1 plus 1 over 3 times 1 plus 1 over 8 times 1 plus 1 over 15. Since we have parentheses, so the priority goes for solving what's inside the parentheses. Here 1, it's over 1. Okay, but what should we do? I have to find the same denominator, which is 3. How? By multiplying by 3 the denominator and the denominator. Okay, similarly the second one, it's over 1, but here we have over 8, so I multiply by 8 above and below, and the same idea is repeated here. It's 1 over 1 plus 1 over 15, so I multiply by 15 in order to have the same denominator, because if I don't have the same denominator, I cannot add the fractions. So here it's 3 over 3 plus 1 over 3 times 1 times 8 is 8, so it's 8 over 8 plus 1 over 8 times 15 over 15 plus 1 over 15. Now let's solve what's inside the parentheses. Here we have the same denominator, so I simply add the numerators. 3 plus 1, it's 4, and the denominator is 3, times 8 plus 1, which is 9, over 8, times 16 over 15. Okay, when we have the same denominator, I simply add or subtract the numerators. Now, what do we have here? Multiplication of fractions. So it's easy. I have to multiply the numerators by each other and the denominators by each other, then simplify. Or simply I can say here we have 9 and 3, both are divisible by 3. 3 divided by 3 is 1, and here 9 divided by 3 is 3. We also have 4 and 8, or 16 and 8. Okay, you can think in both ways. 8 divided by 8 is 1, and 16 divided by 8 is 2. So it's 4 times 3, 12, times 2, 24. 1 times 15, 15. Here I can also say that 3 and 15 both are divisible by 3, or here 24 divided by 3 is 8, and 15 divided by 3 is 5. Look dear, while solving such a question, you have to be full concentrated, okay, since any error with any number would cancel the remaining expression. So please take care. Here we have plus times plus times plus. Priority according to PEMDAS rules goes to multiplication. So 1 over 3 times 1 is 1 over 3. 1 over 7 times 1 is 1 over 7. I write it in the expression. It's 1 over 1 plus 1 over 3 plus 1 over 7 plus 1 over 15. Here, the least common multiple. To have the same denominator, we have 3, 7, 15. 105 is a multiple of 3, 7, and 15. Or simply, you can say here, for example, make a common denominator between 1 and 3, and the same thing between 7 and 15, and then add the two together. Or you can find the least common multiple of the three numbers. So it's 105 over 105 plus 35 over 105 plus 15 over 105 plus 7 over 105. Okay, where does this number come from? It's the multiplication of 3 by 7 by 15. Now we have the same denominator, so simply I have to add the numerator. 162 divided by 105. Since the sum of the digits is a multiple of 3, so I can divide them by 3. 162 divided by 3 is 54, and 105 divided by 3 is 35. I can divide them by 2 since 35 is not an even number. The sum of digits of 54 is divisible by 3, but 35 is not divisible by 3. I can divide them by 4, by 5, since 54 is not divisible by 5, either by 6, by 7. I can consider it as an irreducible fraction. Now we have division and addition. Priority goes for division, and we know that we have to write the first fraction as it is, and then division is replaced by multiplication, and write here the inverse of the second fraction. So instead of writing 4 over 7, I have to write times 7 over 4 plus 3 over 10. It's so easy here. I have multiplication and addition, so priority goes for multiplication. Now multiply the numerators by each other and the denominators by each other. 2 times 7 is 14, and 5 times 4 is 20, plus 3 over 10. 14 and 20 both are even numbers, both can be divisible by 2, so it's 7 over 10 plus 3 over 10. Did you see here? I divided it by 2 to have the same denominator. One of you can say that I don't want to divide. I can multiply 10 and 3 both by 2 to have 20 as common denominator, and then later I will simplify. It's okay, you can do like this and you will get finally the same answer. Here we have the same denominator, which is 10. So 7 plus 3 is 10, and write the denominator as it is. 10 over 10 is 1. That's the solution of part. Now F, we have multiplication, division, and multiplication. What to do? According to PEMDAS, multiplication and division has the same priority. If we have signs of same priority, I have to start from left to right. So 1 times 2 is 2, 4 times 5 is 20. Divide should be replaced by a multiplication sign, and write the inverse of 4 over 7, which is 7 over 4 times 3 over 10. What do we have here? I have to multiply the numerators by each other and the denominators by each other. So here we have 2 times 7, 14. 14 times 3 is 42. And here 20 times 4, 80, times 10 is 800. So it's 42 over 800. Divide them by 2. You will get 21 over 400. Okay? Part G. We have multiplication, addition, and then multiplication. The priority goes for multiplication. So I can simplify here, since I have times 5 divided by 5, times 7 divided by 7. I can simplify them with each other. So what's left here? It's 2 over 10. Or you can say that both are divisible by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. plus what do we have here? I can simplify by 3 and simplify by 17 also. Okay, so the answer is here we have only 1 left, and in the denominator 5, so it's 1 over 5 plus 4 over 5. You have the same denominator, so let's add the numerators. 1 plus 4 is 5 over 5, which is 1. Okay, please, you have to write these on your copybook. Thanks for your attention.